So today we're going to start a new topic, and that topic is CC15, and it's on the energy changes that occur during chemical reactions. And underneath I've written the equations for two chemical reactions that we've come across recently. The first one you should hopefully recognize as respiration. So you're getting glucose and oxygen reacting to form carbon dioxide and water. And when we talked about respiration, and we talked about energy, we said that energy was released as respiration took place. So we use that word released and not the word produced, because energy cannot be created or destroyed. So you cannot say energy is produced, but you can say that energy is released during the respiration reaction. And then the reaction underneath, you should hopefully recognize as being photosynthesis. And in terms of energy, this was the opposite. This reaction did not release energy. This reaction absorbed energy. And it absorbs this energy from the sun. So the top reaction, chemical reaction takes place, energy is released, that's respiration. Photosynthesis, in order for this chemical reaction to take place, energy must be absorbed, and that energy is absorbed from the sun. And we had two words to describe these reactions. We had the word exothermic and we had the word endothermic. And we used exothermic to describe respiration, and we used endothermic to describe photosynthesis. And by exothermic, I just mean a reaction that releases, not produces, releases energy. And by endothermic, I mean a reaction that absorbs energy. You do need to know the difference between the two. A simple way to remember it, exo is kind of like the word exit. So you can think of the energy exiting the system or the energy being released from the chemical reaction. Energy is leaving. And then endo, a slightly more tenuous link, but the second letter is N, and the second letter in the word in is N. You're putting energy in so that the chemical reaction can take place. So how exactly are you going to know if a reaction is exothermic and it's releasing energy, or if it's endothermic and it requires energy to take place? At the moment, we're just talking about energy and it's all a little bit abstract. But if we take a look at the second part of this word, thermic, okay? Thermic, like the word thermal, refers to heat. So when I'm saying an exothermic reaction releases energy, it's releasing energy in the form of heat. So the chemical reaction is releasing heat, and an endothermic reaction is absorbing heat. If you've got a chemical reaction that's releasing heat, you're going to get an increase in temperature. And if you've got an endothermic reaction that's absorbing energy in the form of heat, you're going to get a decrease in temperature. So when you're trying to figure out if something is an exothermic or endothermic reaction, what you really want to see is, are you getting an increase in temperature or are you getting a decrease in temperature? And to measure that, you are simply going to use a thermometer. So what I'm going to draw out here is a reaction beaker. And in my reaction beaker, I am going to call this solution A. And I'm going to react my solution A with my solid B. And I'm going to have a chemical reaction, which I'm going to write underneath as A plus B, and my imaginary product is going to be AB. So I'm starting off with solution A, I'm going to drop in my solid B, and I want to see if this chemical reaction is endothermic or exothermic, okay? To do this, I need a thermometer. So I'm going to draw my thermometer. Okay, so this is a thermometer. And what I'm going to do is I'm going to need to record the temperature at the start. So before I've added solid B, I'm going to record the temperature of solution A. And I'm going to call that my initial temperature. So before I've started the chemical reaction, my initial temperature, let's just say, is 23 degrees Celsius. And then I add solid B to solution A. I get a chemical reaction taking place. And I notice that my temperature increases. And I end up with a final temperature of 43 degrees Celsius. Because I've seen an increase in temperature, I know that my reaction is exothermic. It's after releasing energy in the form of heat. Because it's releasing heat, I've had an increase in temperature. Okay, final temperature was 43. I've had an increase in temp. If it's an increase in temperature, I have an exothermic reaction. And if I wanted to measure an endothermic reaction, I would do exactly the same thing. I'd find my initial temperature, I would do the chemical reaction, and if it was endothermic, I should see a drop in temperature. So my final temperature should be lower than my initial temperature. Then I could say I had a decrease in temperature. Then I could say the reaction was endothermic. So when you are doing these chemical reactions, you would use something slightly more sophisticated than what I have drawn. Instead of just doing the reaction in a beaker, what you would typically use is a polystyrene cup. You'll notice that this polystyrene cup also has a lid on it, and they've just cut a hole in the lid so that the thermometer can still go through. And then they put the polystyrene cup into a beaker. And a really common exam question is they will ask you, why do you use the polystyrene cup? And you will answer that you use the polystyrene cup. This is all in your booklets, because polystyrene itself is an insulator. And by that word insulator, I just mean it's not a conductor. It doesn't allow heat to pass through. So what your polystyrene cup is going to do is that all of that heat that's released during the reaction, the polystyrene cup is going to trap that heat inside so that you get an accurate reading on your thermometer. You don't want the heat that's released during the reaction to just escape from the beaker. If it does, you don't get an accurate read on your thermometer. So anything that you can do to keep that heat in is going to give you a better reading. So we use a polystyrene cup because it's an insulator. We put a lid on the polystyrene cup, and we also put the cup into a beaker. And the reason for that, it says here beaker for support. Okay, yes. But also between the polystyrene cup and the beaker, you have a layer of air. And air itself is also an insulator, and air will also stop the heat escaping. If we scroll down to the questions, scroll down to the questions on page 38. Okay, so I have given you a table here in question number 1, which we're going to go through together now. The temperatures of reactions of zinc, magnesium, and nickel with hydrochloric acid were measured, and the results are shown in the table. So you've taken these 3 metals, you've reacted each of them with hydrochloric acid. You've taken the temperature at the start each time, and then you've taken the highest temperature reach, and you're asked to calculate the temperature change. Okay, the first one has been done for you. The difference between 24 and 19 is 5, so you've had a 5-degree increase. Because you've got an increase, even though it's only a small one, you would say that this is an exothermic reaction. In the next reaction between calcium and hydrochloric acid, you again see that you've got an increase. And this time you've got an increase of 38 degrees Celsius. So again, you've got another exothermic reaction. In the last reaction, you see you've got an increase of 11 degrees Celsius, so another exothermic reaction. And what these numbers will tell you is not only that all 3 reactions are exothermic, but the temperature change will also indicate which metal is the most reactive. So you see when you react calcium with hydrochloric acid, you get a large increase in temperature, but when you reacted nickel with hydrochloric acid, that temperature increase was a lot smaller. This tells you that calcium is the most reactive metal, zinc is the next most reactive, and then nickel is the least reactive. So there is a link between the amount of heat energy being released and the reactivity of the metal. The more vigorous the reaction, the more heat that's going to be released, the greater the temperature change that you're going to see. So a classic example of that would be an explosion. Obviously, very, very reactive. You get a lot of heat released during an explosion. Can you please, for me now, complete the rest of these questions. So finish off question 1 and work your way down to question 5. Don't go further than question 5. Do them by yourself first, and then, so press pause, do them by yourself, and then press play when you are done, and I'm going to go through the answers. Okay, hopefully you've actually done these questions for yourself. I'm going to go through the answers. It says magnesium is more reactive than zinc, but less reactive than calcium. Predict the temperature change for a reaction between magnesium and hydrochloric acid. If it's telling me that it's less reactive than calcium, then it's not going to give me a temperature change of 38 or above. It's telling me it's more reactive than zinc, which means it should be a temperature change more than 11 degrees. So to get the mark here, any answer that's greater than 11 to show that it's more reactive than zinc, but less than 38 to show that it's less reactive than calcium is going to be just fine. So I'm just going to pick 20 degrees, but if you're above 11 and below 38, you've got the correct answer, you'll get a mark. Reactions that give out heat are just called exothermic reactions. Exothermic reactions. It's just another reaction which would give out heat. So I have included a list of exo and endothermic reactions further up in your booklet, and that just gives you kind of reaction types in general. So combustion reactions are always exothermic. Combustion is when you burn something. So if you're burning something, you're giving out heat. Neutralization between acids and bases. They are exothermic. Displacement, we've looked at some displacement reactions, but you could just give me something more general. In your answer, you could say, for example, the alkali metal reactions that we looked at, you reacted lithium or sodium or potassium, you react any of them with water, that's going to give out heat. You could say an explosion gives out heat, burning something gives out heat, which is combustion. So there's lots and lots of potential answers there. 4, a student investigated magnesium hydrochloric acid, exothermic, which 2 measurements? So if you're asked which measurements you need to take to show something is exothermic or endothermic, the measurements you would need to take are what is in this table. The initial temperature and the final temperature. And you usually take the final temperature as the highest temperature reached, which is what I've got here in this table. Okay, when the temperature stops increasing and you get a maximum temperature, that's going to be your final temperature. So they're the 2 measurements that you would need. How are the measurements show that the reaction is exothermic? If it's exothermic, what you should see is that the final temperature is higher than the initial temperature. In the next video, I'm going to go through why some reactions are endothermic and why some reactions are exothermic. And once we have gone through that, then you can use that information to access the rest of the questions. But watch the next video so that I can explain why some are exo while some are endo.